Well, welcome everybody to May's meeting at the Astronomical Society of Frankston. A few people here tonight, a few still coming in. I'll start off as usual by handing round the idea, question, suggestion box, as well as the roster for viewing nights at schools and likely upcoming community groups. If you're interested in attending or can attend, please note your name down. For those of you who are new here tonight, there are a few new faces. I welcome you to our meeting. My name is Skilton, and I hope you enjoyed the evening. The structure of tonight, at committee's request, we're trying a bit of an experimental rearrangement of segments, which probably would have occurred last month at last month's meeting. So what we'll do is I'll have a bit of a preamble up front, and then we'll go into the main speaker, the main topic tonight being Marty Rudd and Roger Vodicka from the ASF. We'll be talking about the Leonids from Alice Springs. And after that, we'll break for a tea break somewhere around 9:05, 9:10. Then we'll reconvene in afterwards for the information segments and the video next door. So the video will be going in the library at the same time as the information segments are in here. Right, so I would remind everyone who has name tags to please show your name tags so that everyone knows who you are, not least of which is me. Speaking of which, there are a couple of people that we seem to have lost track of in our membership database, and I'm wondering if anyone knows if they're here tonight or knows of them. There's a Kathleen McGuinness who didn't leave her address, unfortunately, so we'd be very keen to get her address. Christine and Charles Cornwell, whose address has actually bounced on their newsletter, so their newsletter came springing back to us. And Darren Andown, whose email address is also similarly bouncing. None of those here tonight? Never mind. Right, the raffle is about to go around. For those of you who wish to partake in some whiskey and a book on the Sun and the Moon by the National Audubon Society and John Ribbon's Empire of the Sun book. I assume that's 3 prizes, David? 3? So please tear off only one half of the ticket, otherwise the other half is not there to be drawn. Strange but true. Right, well congratulations to the following members for reaching their milestones. And before I start that, I would point out it's probably going to get a bit cool in here because the air conditioning is actually on and it can't be shut off for an hour. So it will shut itself off automatically somewhere around 9 p.m. So if you have your coats, it might be best to wear them in the meantime. Right, congratulations for reaching the 5-year mark to Julie Foster and Russell Thompson, who is here tonight. Congratulations on reaching 5. Also the 5-year mark is Ron Vassell. 3-year mark is Sally Zeta. Oh, well done, Sally. And new to our group are Dorothy and John Grierson, Hal Schuster, David Wiley, and Rhonda and Ray Young. So congratulations on those for joining us or being here for a while. Speaking of David Wiley, there's a picture of David Wiley. He's the one on the top of the ladder here. And Bruce Tregaskis, who's sitting in the front row, is the one in the middle, standing next to our society's, at that time, 12.5-inch B.J. Smith telescope. And it says the pride and joy of the Astronomical Society of Frankston. So he sent that one in. It's from 1970 in the local papers, standing in the middle of the field. Used to be a housing estate with a big telescope. Right, the latest edition of Scorpius has been posted out. If you haven't received yours yet, you are financial, then do come and see Sally. We'll put up her hand and we'll gladly take your details if we have accidentally missed you out. Is there a librarian here tonight? Yeah, Andrew is here tonight. Again, if during the tea break you're interested in browsing through the library, please feel free to go around to the other room and you might wish to borrow something. Right, since we last met, there have been a number of viewing nights. We've had the University of the Third Age group from Phillip Island came down to the Rise Education Centre on the 25th of April. We had 38 of them under 100% clouds, so they were nevertheless very, very happy. They had plenty of red wine and us in as well. They had a very nice evening. On May the 1st, we had Langwarrin Park Primary, and we were a bit surprised there with about 50% more people turning up than what we expected, and there were 120 there, and they all went off to the planetarium the next day, so they were really happy about that, about having us the night before. May the 3rd, Public at the Rise, we had 75 there. We actually expected around 100 based on the number of bookings, but fortunately they all didn't turn up, and many were actually from Year 2 at Higher Primary. May 6 and May 9, St Francis Assisi Primary from Mill Park, and a bit of us down at Camp Manual, and there were quite a few there on those nights. Right, working bee in May, got an awful lot achieved, and a lot of people turned up for that, and got quite a lot done. David, would you like to say something about the working bee? John?
The last one or the next
one? The last one, both.
Last one was good, next one's going to be better. Next one, we planted how many trees? 150 trees, last one. Next one, there's no more trees to plant, a few little areas to be levelled out. Not a great deal actually. If we get the paint, yes, and some paint, it's alright, it's only
and the caravan was painted a nice battleship grey, so it's really going to battle. Right, there was the inaugural scope of binocular teaching day. There's another one coming up. Would you like to say something about it?
Last month we had our inaugural telescope learning day, which was a success, as you would have read about in Scorpius. We decided to run it monthly for a little while, to see how it goes. If anyone's interested, I haven't had really any feedback as yet about running it monthly. But what we were going to do, because we didn't cover that much on the first one, we will just continue on with that. But there's a lot more to learn, and this week coming up, this Saturday, we're going to be teaching on star atlases and all the different kinds of star atlases you can buy, how to use them, how to use the planisphere and that sort of thing. And if someone wants to come up with a laptop computer or something and show some star mapping programs on a computer, that'd be great. And then we'll have some telescopes on the ground as well, hopefully a few different sizes, so you can get a load of, have a look at what sort of telescopes there are available. And if you've got a new telescope that you've just bought in the meantime, bring it up and we can show you how to use it. I would like to have a bit of a show of hands to see if people are still interested in that sort of thing though. Any people? 1, 2, 3. Oh, we've got about a dozen there, so that'll be, we will continue with that. So it starts 3 o'clock this Saturday afternoon. This time we're not going to supply the barbecue, so bring your meat along. So we'll have the barbecue there, but you've got to bring your own food. We'll go into the viewing night as well. And 11 o'clock on that day, 11 o'clock in the morning, I'll post a message on eScorpius saying whether it's on or off. And if you don't get eScorpius on the email service, then you can give me a ring at around that time on my mobile number, which is listed in here, and I'll let you know whether it's on and off. If it's raining or, very overcast or a day, it's off. It's off. I'll have to, we'll cancel it, alright? It's cancelled if the weather's bad, alright? So that's the telescope learning day coming up.
Ian, your basic astronomy classes? Yes, please.
I made an announcement a couple of meetings ago about running astronomy classes for the weekend, and I got about 7 or 8 names from people over several meetings, and I'm trying to get a venue. I've inquired at a few community houses, Mount Martha, Mount Eliza. I thought I had Mount Eliza, but I'm not quite sure. They couldn't give me a definite answer today. The other alternative is to come here, meet here. I'm trying to keep the cost down, that's all. There's plenty of places to go if you're prepared to pay the money. But I'm hopeful of Mount Eliza, the community house, but I haven't quite convinced it. Now, if you've given me a name already, if you've got names and phone numbers, could at least perhaps give me your address too, at either look. Alternatively, if I post something, I've got to be posted to seemed to be the day that people were most available. So what we'll do, we'll start it off on a Saturday afternoon. I had penciled in the June 15th, so depending on getting a venue and getting it organised in time. And my phone number, of course, was going to be in Scorpius, this last Scorpius, but unfortunately due to a technical issue, I accepted that it didn't make it to the system and it didn't get included. So it's not in this Scorpius, but it was in the previous Scorpius. If you see me tonight, give me a phone number, and if I've got you on my list, then I'll notify you personally if, of course, it's going to take place and get started. And hopefully there'll be more than one Saturday. And the topics will change. They'll tend to be, of course, the theory type things that you don't have time to do here on a general meeting time. So we'll see how it goes. So if you're interested at all, give me a phone number and your address at thanks for the presentation.
Right, so we're also looking for a coordinator for the loan instruments to replace Ken Bryant, who's quite ill really, and has asked if we can find someone else to look after the ins and the outs of the lone telescope. If you think that you're technically able to do it, anybody, please come forward at tea break and let your interest be known. In the meantime, John Cleverdon has kindly offered tonight to speak to you if you wish to borrow the lone telescope, or we're down on the list for borrowing it. Right, okay. Coming up for the next meeting, May 26th, there's a penumbral lunar eclipse where it would be fairly difficult to see, in fact quite difficult. If you go to photograph it, about 71% of the moon will be covered by Earth's outer shadow, so it won't be noticeable too much with the eye. Middle of the eclipse occurs at about 3 minutes past 10 in the evening on May 26th. So you might be able to make it out if you've got binoculars or a camera. Also, just to let you know that I've written to the Geelong, Bairnsdale, Albury, Wodonga, Mildura and Bendigo societies asking them for a get-together with our society, either here, there or somewhere in between, given the distances involved. So far the Geelong Society has replied and has invited our society members down as follows. Their dark sky venues on the long weekend in June, so that'll be the Queen's birthday weekend, and is saying that our members would be most welcome to join the ASG down there. Their site is a 1,200-acre sheep station, 30 kilometres north of Geelong, where they enjoy dark skies plus excellent accommodation in bluestone shearers' quarters, fully equipped kitchen, bunk beds, sleeping, each accommodating 4 people, plus full use of the property while they're there, bushwalking, fishing, gold panning, all at a cost of $20 per person per night. Bring your own food and bed linen, and telescopes of course. Should anyone here be interested in the idea, they've probably got room for about 18 of our members to turn up. So first 18 come forward. We've never visited the Geelong Society before. It's a bit surprising when you consider it's a relatively small bit of water in between us and them. So here's the first opportunity of an inter-society gathering for this year.
Is that Friday and Saturday night?
I think so, yes. So if anyone's remotely interested, please come forward. I'll certainly will be going to that. Right, okay, well without any further ado, I might ask our main speakers to come forward. Roger Vodicka from the Meteor section of the ASV, and Marty, as you all know, from our Meteor section, and they're both on the East Australia Meteor network as well. Welcome to our society, and
I'm here tonight to do a little talk on the Leonids meteor shower, which I think most of you might have heard about, occurred last November last year. Myself and a few other members from ASF and members from the ASV organised a bit of a trip to go to Alice Springs to observe the Leonids meteor shower. And we're basically here tonight to show you what we saw, to show how much of a good time we had, and tell you all about the Leonids and what's predicted in the future for it. So without further ado, I'll hand over to Roger. This is Roger from ASV. We'll start off with the talk for you. So, thanks a lot. Turn the laptop on, does it?
Well, hopefully tonight all the technology's going to work, because we've got a pretty sort of multimedia presentation on this evening. A lot of the work that Marty put into videoing the Leonids is quite spectacular, so I hope you will enjoy that tonight. And hopefully it gives you a bit of a feeling of what it was like to be in the middle of Australia observing this meteor shower under a nice clear dark sky. There's a bit of sound there as well, but it's not very loud. This is a short video that Marty took from, I think, Heale, looking over Alice Springs. It's not a very big town. So again, just showing you Alice Springs, very small town. It doesn't take you very long to get far away from the lights. The accommodation, I think David Goulding was responsible for this, organising the accommodation, which is, forget the name. There it is, That's it. It's a place that must have been there before. Yeah, very good accommodation. Unfortunately, David didn't join us on that time, but commend him for his choice of accommodation. So why did we choose Alice Springs? There was a number of places we could have gone. In the world, obviously, you could go to somewhere like China, but it's obviously very expensive. Alice Springs has got a number of advantages. Higher latitude than Melbourne, so the radiant where the meteors are here to come from is going to be higher up. Good longitude, that means it's in the perfect time for when the shower is going to be at its peak. The weather is actually quite good at that time of the year, and of course you're in the middle of Australia, out in the, away from all major cities, so you've got good quality dark skies. So what was the aim of the trip? We had a number of aims. So obviously to observe the Leonids, it was going to be predicted to be a very good shower, so we go out and enjoy ourselves there, collect some good data. We've been observing meteor showers for a number of years. This was our first time to have a look at a major storm, so we're interested in getting some good data. Also mainly because there's not a lot of observers that are in the Southern Hemisphere, so this was a unique opportunity. Obviously have lots of fun, see the outback, and we were hoping to see the greatest astronomical event we'll ever see in our lifetimes. That was the promise. So this is a bit of a top 10 of best things you could ever see. This is obviously a bit personal, other people may have different top 10s. Murchison Cramond meteorite impacts. I wasn't there for those, but I'm pretty sure they were quite good. Crab Nebula explosion. Alright, if I would have seen that, that would have been a pretty good display as well. Any later solar eclipse is always very good. Shoemaker Levy 9, the Jupiter impact, if you remember that one, that was definitely a highlight in my observing career. Birth of the Universe, again, wasn't around for that one. Aurora 1990, I don't know if anyone was there for the Vostok in Geelong. Mentioned Geelong earlier. That was a very good aurora that went past the zenith, most spectacular one I've ever seen. Comet Vodicka a number of years ago, that was very memorable as well. Well, that one's a bit. Leonids 1998, I would have rated the second, and obviously Leonids 2001 has been the best thing I've seen so far. Maybe slightly biased.
So the Leonid meteor shower, we're up in Alice Springs, and we're hoping to have a good display. Over the years, the Leonids have produced quite fantastic meteor showers, in fact storms, as they've been known to be called. In 1833, the first recorded storm occurred over North America. It produced literally thousands of meteors, and as you can see, this is actually a carving, I believe, from 1833. I believe it was done by the Mormons. And you can see how the perception of the storm in that year was to them, literally raining stars, as they thought at the time. The Leonids has a period, or occurs every 33 years, as its main meteor shower. In 1899, which is approximately 33 years later from, actually is, 1866, there were 2,000 to 5,000 meteors per hour seen. This was down from 1833, but still rates in comparison to your standard meteor shower or the number of meteors you see if you go out on a clear night. You can see 5,000 meteors an hour would be quite fantastic to see as it is. In 1867, 1868 and 1869, and the rates gradually decreased again back to their normal rates, which I think usually 30 an hour or so. In 1899, due to previous Leonid meteor activity, there was quite a lot of hip-hop, especially in America, about expecting a huge meteor storm. It was publicised in papers through Europe and the United States, but unfortunately there was no storm actually occurred. Activity was only between 50 to 100 per hour. At the same time, this was actually described as the worst way suffered by astronomy in the eyes of the public, as because of the hype that was put behind this, everyone's gone outside and literally seen 50 meteors an hour, and they were basically told, go outside and you'll see thousands and thousands. So it was almost lynching year for astronomers, unfortunately, back then. What was later calculated was that the meteor stream had passed or encountered Jupiter in 1898 and Saturn in 1870, which actually moved the meteor stream away from its calculated, well, what they thought was the path of the stream. So the Earth actually missed the meteor stream almost completely. In the early 1900s, 1901, 1902, the activity actually decreased back to normal rates again. From 1928 to 1939, there were actually no major outbursts, with the main meteor rate approaching only about 240 per hour. Then we come on to 1965 to 1969, especially in 1966. In 1965 the rates started increasing dramatically up to about 120 per hour, which is about 4 times what you usually see. So there was some expectation of a storm possibly occurring in the next few years. So a lot of people prepared themselves, hopefully for what possibly would be a very good storm or shower. On November the 17th, of 1966, for observers, especially in western United States, and particularly Arizona, between 2:30 and 6:40 a.m., the rates approached 40 meteors per second, which approximately translates to about 144,000 meteors per hour that was seen over America. It actually surpassed anything that anyone had actually expected. The eastern United States, which is, I suppose, probably only 6 hours or so the other side of America, the rates had dropped back down to 200 meteors per hour. So what was observed from this, with 144,000 meteors per hour on one side of America and only 200 on the other, the peak, or the area of space that all the meteors are floating around the Earth passed was a very small band, and the Earth passed through it very quickly. So it was a very large, or a very quick peak with the amount of meteors that was seen at that particular point in time. From 1967 to 1969, the rates gradually fell back down to their normal rates again. In more recent times now, in 1994, the rates began to increase again, with the next 33-year period approaching. In 1995, rates approached 35 metres per hour, and in 1996, we had approximately 60 meteors per hour. In 1997, it was approaching 130 to 150 meteors per hour, as seen in the Pacific region. In 1998, myself, some of the ASF and ASF members, we all went to Woomera as predictions for a meteor shower were predicted for them as well. As it turned out, it became a bit of an anomaly in that the predicted night that the meteor storm was to occur was actually not a lot seen at all, almost nothing seen at all that night. We were there for about a week, and generally when you go observing for a main meteor shower, you tend to observe the night before, the night predicted, and the night after, just in case anything happens. We were lucky because we were out the night before, and we actually saw quite an amazing display of fireballs, which are meteors generally said to be greater than magnitude -4. It was widely advertised once again, and of course most people slept in the night before, and the night that it was due to occur, everyone's gone outside and seen nothing, and the same thing was almost lynching you again for astronomers, unfortunately. But we did see a fantastic display in that 1998 period. 1999, I think America was the best place. Jordan, oh, I suppose, okay, Jordan. Jordan was the best place to see the meteor shower in because it was a small peak. And they saw approximately 2,500 meteors per hour on that night. In the year 2000, there was a slight rate reduction seen with only about 400 per hour. And then we approached 2001, which is, the predictions were actually a lot better than they had been in the previous years before that. Just got a little sound file here, I hope it actually works. I think I've got the link here working. When we observe meteors, we have a little tape recorder and we just turn the tape recorder on and we speak into the tape recorder and just basically say what we see. When we describe a meteor, describe its magnitude being anywhere between 6 and hopefully minus 12 if ever. We try and say if there's any colour from it. If there's a train, which is like the, if you've seen a meteor before that's quite bright, it might leave a bit of a smoke train in the sky. We describe if there's a train and how long it stays in the sky. Also, if it comes from a particular rating or a meteor shower that you're actually out there observing. So I'll just play the sound file and give you an idea of how the recording happens. Now, this particular recording was done by Adam Marsh, who is the ASF director, and he couldn't make it here tonight, unfortunately. Adam tends to get pretty excited when he records meteors. This is quite a bright one as well, so we'll keep going. No. Can I have a bit of a hand here for going in a second? Plug out that sound up. Normal meteors are like that, so reactions like that aren't too common, but when they do, as you can see, we generally like to go off.
What was that noise?
That was Adam Marsh, yeah. Now, where do the dust particles come from that create these meteor showers that we see? In the case of the Leonids, and in most cases, they occur because of comets. As comets go around the sun in their orbit, they leave behind a trail of dust, which is can be seen as the tail. It does come close to the sun, most people can observe it. There's been a couple recently that have been quite easy to see. In the case of the Leonids occur because comet Tempel-Tuttle orbits the sun. The Earth intersects the comet debris that's left behind it, and as the debris passes through the atmosphere, because it's high velocity, it basically tends to burn up in the atmosphere, and we see what is known as a meteor. This is just a little demonstration of how, for the Leonids, the Earth goes through the dust particles, and from the direction meteors come from, you can see Leo from the arrow there. And so that gets the perspective that the meteors always tend to come from the constellation Leo, and then the Earth continues through. Meteors come from an area in the sky known as the radiant. Meteors actually travel together in a parallel path, but to an observer, they appear to radiate from the same spot. And as you can see in the picture, it's like a ray that diverges into the distance. It's actually parallel, but to your perception, it tends to go to a single point. And that is actually the same for meteor showers. In this diagram here, you can see how the top picture shows someone with meteors raining down on them in a parallel path. And then here on the side, you actually have the perspective of how that person would see each parallel meteor from different angles. The Leonids come from an area of the sky, from the constellation Leo. Just a little line up the top there. And that's the area in the sky that you would see. Leo is actually in the sky presently at the moment as well. Here we can see the constellation Leo, the sickle, and this is the area just in the sickle that the Leonid meteors tend to come from. And that's sort of a rough plotting diagram that I did from the Meteor, from the Meteor video that I'll show later on, of how the meteors that we saw, or I saw from the video, were plotted back onto a sky chart. And you can see how they sort of originate from that central point, the radiant in the sickle of Leo. I'll just hand back over to Roger.
Thanks, Marty. Okay, just a little bit about the observing site. When we got there, obviously we needed a place to observe. We sort of looked around for a few different places. We actually spoke to someone from the Weather Bureau, and they suggested that Bond Springs might have been good. We also had an ex-ASV member that lived up in Alice Springs, and he suggested an airfield north of Alice Springs. Being an airfield, it's perfect, fully cleared, nice and flat, so we chose that as a place to observe from. As far as observing meteors goes, observing technique, as Marty mentioned earlier, involves only a few bits of simple equipment. The main piece of equipment is a comfortable deck chair. As you can see, the two photos on the right hand side, people lying down on deck chairs, need to be comfortable, need to be warm, and then basically just lie down, note your direction, note the conditions of the sky, and then record what you see. In addition to that, you can use pen and paper instead of a tape recorder, cameras and film, and just recently, as Marty will show later on, the use of videotape. So this was the night of the maximum, and as you can see, the centre of Australia had very clear skies. Down in the south, they had quite a lot of problem with clouds and things like that. So we're actually very lucky that we had very good clear skies on the night. We had planned to make a move from Alice Springs. The other advantage of Alice Springs being that you can travel north and south quite quickly. You've got the Stewart Highway. And if either the north or the south clouded out, we had prepared to make plans to go north or south. Luckily on the night we didn't have to go far at all. There's a bit of a blow up of that. No cloud whatsoever. So here's the night of the maximum. We've got a few people there set up with their deck chairs, a few telescopes. You can see the windsock in the background there from the airfield. And as you can see, very, very nice and clear sky for the night. And you can also notice people wearing t-shirts, was nice and warm as well.
Then a little compilation of the. There was actually a lot of editor's work with the sound files that he put together. So I'll pass the message on to Adam that he got a little cut for that one as well. There was one point at the end of the, or towards the end, where you heard Adam saying every camera got it. Unfortunately for Adam, he left his lens cap on the whole night on his cameras. So he actually had two cameras set up, one with a wide lens, the fisheye lens on it, which some of the photos showed. Another one, I think, had a 28mm lens on the other camera, and he left his lens cap on the 28mm camera. So we always like to tell Adam now that almost every camera got that video. What we've got now is. When we went up to Alice Rooms, I took up a image intensifier, which was kindly lent to us by Barry Clark from the ASF. Behind the image intensifier, I've put my video camera. What the image intensifier basically does is magnify the amount of light that can be gathered through a lens, basically. It's basically a light amplifier. And what that allows us to do is videotape quite a wide angle of view, down to magnitude about 6. So basically down to the limit of what you can visually see out in the sky. I'll just do a quick demonstration on what it looks like to look through an image intensifier. I'll just pop the screen off here. This is the setup that I took with us. It's basically I've just got a Minolta lens on the end of the image intensifier, which is this white unit here. And behind the image intensifier, I have my video camera. It's a little digital video camera. And obviously there's light coming off the screen as well. It's basically almost in pitch black, this you can see quite a fair way away, and the light actually allows you to so that's basically what it looks like through the image intensifier. You only need a real small amount of light to make this thing work. So it works quite well with stars, recording stars. Yep. So with the image intensifier, with the video camera all hooked up, we were hoping to get some meteors on video. And as it turns out, we did. So I've just put together just a little 8 or 9 minute video here of the setup we had and the meteors that we got on video. So I hope you enjoy this little one as well. That's basically what it. Oh, and I had some Pinnacle home software, which is like a movie making software. So it allowed you to download the digital video cassette tapes that I've taken up with Alice Springs, download them onto the computer, and then do the editing to create this thing. There's actually a couple of fields of view that come up on the video. one of the first ones is of Leo, or one of the ones that are in there of Leo. And that's basically the area of the sky that comes up on the video. The sickle in that shape, you'll see the main stars. A lot of these faint stars actually didn't come out, but the main sickle is quite apparent in the video. And towards the end, there's actually a small section as well, I think, of Canis Minor in there as well. Just up in the top left-hand corner, you'll see, I think it's Procyon, you know, correct me on that, Procyon in Canis Minor. And towards the end of the video, I actually started videotaping the opposite side of the radiant, so the opposite area of the sky where the meteors were coming from. And it was actually quite an interesting effect that we actually saw meteors just dropping down out of the sky rather than going overhead. And that's an area of the sky in Phoenix. The main stars that you'll see on the video, it's this bright star here, and you'll see this arc of stars as well, quite clearly.
Oh, come on. Man? As if he's moved that man. Shine. Again. Richard? Come on. Not it. And good. Enjoy this in the empty camera. 6 and an Alta SRT 100, the image intensifier with 28mm lens, and then an Alta SRT 300.
best of them. I actually lost a little bit of quality from the transfer from the video to the computer, and then with the editing and so on and so forth. Also, it was probably the first time that I really had a real good go at the intensifier and the video camera. And from the experience and the video and the results, I've actually learned quite a lot about how the system works. And recently we went up to the Tregaskis and I did a little bit of video work there. And I've actually got a fair bit from that expedition as well. But the quality from the Tregaskis is actually a little bit better than, or the picture quality is a lot better than what we've just seen here. So with all that video data, it wasn't all just for fun. What we can do is plot back the meteors by watching them on the television screen, getting a really good indication of where they travel through the sky, and then plot them back onto a chart, which I've done here. What we can do then is trace back the line of meteors to find a central point. Hopefully that should be the rating, which apparently, or actually it is. The good thing about this sort of work with the video work, it's a lot more accurate than plotting manually, whereas you see Meteor and then you have a star chart in front of you and you draw it on the star chart there and then. The discrepancies can be quite large in your perception of where you actually saw it go. So this is quite an accurate way of determining exactly where a meteor radiant or meteor shower radiant is. And it's just a little shutdown. Next we come up with the predictions and the analysis of our observations. The reason why we went to Alice Springs was because of the predictions that we'd been given. Australia was actually one of the best places to see this particular meteor shower this year, as well as America. There were two apparent peaks, or predicted peaks, in the meteor shower. One peak was to occur over America, then it was going to be a lull in between America and Australia. And as the Earth passed, another part of the stream would see quite a large peak again, which is apparently what happened. There are two competing models on how the stream dynamics work. One is by Asher and McNaught, who have been doing quite a lot of work and impressive work on doing these predictions. They've been very accurate up to present. The other model was by Linsemann, which I believe is a Norwegian fellow, I think, and a group of his friends. They got together and decided to put together a different type of model. Both models predicted that we would go through three different streams. On the bottom right-hand side there, we have a predicted area in space. The blue line in the middle is where the Earth would travel on the particular days, and the round circles are where different streams will be in space when they were laid and when the comet went past in that particular year. So, for example, a stream was laid in 1965 by the comet, and that's where the stream would be compared to the Earth travelling through in 2001. As you can see, the Earth was to go through a stream that was laid down when the comet went past in 1767. The Earth would skin through that one and then go through two streams here. One laid down in 1866 and the other one laid down in 1699. And that's like a meteor view of what it was going to do just before it slammed into the Earth. The first peak here in America, as you can see, America's just here, and this is a 1767 stream of meteor particles in the sky, and that's the face of the Earth that was going to go through that part of the stream on the morning of November the 18th. A few hours later, the two other streams that were going to be predicted, the 1699 and the 1866, that's the view of the Earth as the Earth was going to go through those two streams, and Australia is just in this part just here. So we were just in Alice Springs just here. So we had quite a good view, a good chance of seeing a very good meteor shower. I'll pass on to Roger.
Right, here are some observations that were done by different people. These were done by Lance Kelly. What he's done here is he's plotted the time of UT here across the bottom and versus the number of meteors that talk per minute. So you can see there's a bit of a peak occurring at about 18 UT, with maximum about 25 meteors per minute. These are some of my own observations. These are the hourly rates, number of meteors per hour. What they typically do is, in order to be able to standardise the activity of a meteor shower, they correct for the radiant elevation. So people that see the radiant low on the horizon will obviously see less meteors. So at this time the radiant was fairly higher, but still these are uncorrected values, and they show about 1600 to 1800 per hour. Also, you can see a bit of the structure of the stream appearing there with a couple of small peaks there. Most of these observations were done in few minute intervals. This is a preliminary look at all the observations from around the world. The International Meteor Organisation compiles the results from everywhere. They have a standard way of observation, and all of our observations that we conduct are sent to the IMO. Observations are then provided to professional astronomers. In fact, people like Robert Nord have benefited from observations over past years in order to refine their models of how these streams actually work. So a lot of the early observations from 95 to 2000 were used to refine their models and produce their predictions, which came only within 10 minutes of what actually happened. So here's some data, as Marty talked about earlier, the peak in America, and the dotted box there shows the peak that we saw in Alice Springs in the window that we had before, between the radiant rising above the horizon and the sun coming out. Also, the other thing that we really noted was that there was a good distribution of very bright meteors during the shower. Normally the showers have an average magnitude of meteors of about magnitude 3. What we noticed on the night is that we saw very few faint meteors, and most of the meteors that we did see were around the magnitude 1 and 0 mark. Of course, it's a bit subjective when you see a meteor flying across the sky and having to estimate the magnitude. We normally try to estimate within 1 magnitude, but as you can imagine, if you've got 25, 30 a minute, it becomes quite hectic. And you can notice that I didn't call many 0 magnitude meteors. This shows a little bit about the 2 different models that Marty talked about earlier, and how the predictions actually came out. You can see in some of the cases they were within 3 minutes or 4 minutes, which is quite impressive. Considering that before this meteor shower, it's been very difficult to predict when you will actually get a storm happening. So as far as meteor astronomy goes, this is the first of its kind. They've actually been able to predict the storm to within this accuracy, and even give a fairly good estimate about how many you'd see per hour. Okay, I guess where to from here? The 2002 Leonids are unlikely to be good from Australia, from the predictions. I think the west coast of the US is likely to see the best show. So if you do want to see it, go to the US later this year. The only problem is that the moon will be up. The moon will be quite bright. Considering that most of the meteors that we did see were fairly bright, we don't expect that the moon will have a very big impact on what you'll see. We're also looking at always getting new observers into the section, looking at expanding field trips. We had a bit of a lull after the Leonids, because after seeing such an amazing shower, it's very hard to go back to observing showers that show maybe only 10 or 20 per hour. But we have been managing to go on. We've just recently observed the Meteor shower, which is part of Heale's Comet, and we had a fairly good experience with that. And here's some of the references for the published work. A lot of the observations that came into the IMO, I think they got about 10,000 observations in the end. So because it's a voluntary activity, It takes them a number of months before they collate all the information. Okay, and here's a little bit of a plug about the different sections and societies that were involved. The EAMN is a society that's coordinated by Adam Marsh. It includes people that are not part of societies that are on the eastern seaboard of Australia.
That's it. Well, thank you very much for your time.
Well, thank you very much, both of you, for number one, an excellent talk. Really fantastic multimedia all round, as I'm sure you'll all agree, as well as turning what was traditionally a very quiet area of amateur astronomy into a particularly sexy one at the moment. Fantastic effort all round. A great inter-society effort as well.
Thank you. Thanks very much.
And I'm sure if any of you have any questions, they will be more than happy to answer them during the tea break.
Absolutely.
Thank you again. All right, well, I think we'll draw the raffle and then quickly break for a tea break. While David is actually drawing the raffle, I'll just mention that the astronaut Harrison Schmidt, who was the last man to stand on the moon, is actually down here on the Mornington Peninsula on the night of our July meeting, and speaking down here, and I'm in the process of trying to get him to come in to have a talk to us, but fingers crossed on that one for July's meeting. Okay, David, you want to...
Now, raffle, may I just say, Marty and Roger, don't walk back good memories. 98 and right, that was very good. First prize is everyone really liked the talk last month, so they said, can you get a bottle of Scotch? So here we are. And a very, very nice book, Empire of the Sun. So our president can draw his own ticket out. He'll be most happy.
I don't have a ticket there.
There you go.
61.
61. You have your choice of first prize. The yellow one? Yeah. Yeah, 861. Well done. That'll do. Very good. Must be a night time observer.
72.
72?
Yeah. Bruce? Oh, hang on, we've got two 72s.
A or B?
Oh, a B. B.
Which one do you want, Bruce?
There's not even no, this one.
Surely, and last and not least.
Yeah, I'm obviously biasing towards the front there. B84.
Hey, you boys?
I am. Yes, I am. Sorry.
Well done.
Well done.
Well done to the winners. We take kind donations as well to the raffle, and thank you for your support.
John, do you want to say a quick 1 minute?
Quick announcements. Firstly, for those members who haven't got their name tags yet, I've got a number of name tags for newer members, so please come and chase me up over the break to pick up your name tag. And secondly, for members who haven't been to the Briars yet but are planning to go to a telescope learning day or a working day or something similar, I've brought along a number of maps that I've produced showing how to get to the Briars site, so I'll be leaving those over on the desk over there so that you can pick one up over at the break.
And of course, there's what's on over there. You have to pick up the what's on sheet yourself. Now, what we'll do is we'll go next door for the tea break. Given that it's 9:15, we'll reconvene at 25 to 10. The video will start in about 5 minutes' time for those who wish to see the video around in the library. And then at 25 to 10, we'll come in here for the information sessions. For those that wish to see those, like the Aurora and all the others. Okay, thank you. See you after the tea break. Sorry. Very, very
Yeah, no, I'd like to do that. There's a bit of off-track stuff in the t-shirt, so but I want to do that because I'm not going to do my MPAS back packing after
So it was very impressive looking through his telescope. Little memories that stick in your brain.
Az most szomorúan
Not very bright. Well, this is relevant. This guy. With someone sees it. And I keep an eye on it so you sort of know when the light is. You can tell from when it's predictable. People go out to someone rang and said, yes, I expect to do something soon. Nature your eyes. I saw someone rang and said yesterday they could see the morning. So I just saw it tomorrow night, but I wasn't sure. So I thought I came to and that came off the side of my small bit of road down the side. We set up and we found a dark spot there and I observed it now. No one was just like I was set up.
Put it on.
Yeah, but that bit isn't tough.
I know what I'm doing.
Is there any? Yeah, unless you want to go first.
Yeah, because if I do third,
Yep.
all right. Can I still submit the third?
Yep, go for it.
Wouldn't normally say worry about this secret that I do third.
Yep. Oh, that's right. Bob will start if you like. Yeah. Yeah, you can go around. That's right. The video's already playing next to it, so.
This is the one?
Yes.
That's right.
Okay, well, we'll begin first of all with Bob with the Sky for the Night. The video next door is all about Werner von Braun, and we'll go through the segments.
Okay.
I kept one of those books for you. That's the time.
Do you want the lights down, Bob?
Can they be just put down a little tiny bit? It's a bit too dark, that. Can I...
There should be there's a presentation on here.
Yeah. Wait, what was... Oh. Okay, can I get going?
Yep, okay.
Video.
I'll just go around up in the others.
Oh. All right. Good evening. The usual blurb about the planets. We have a slight movement away of the planets, beginning with Mercury. It's now one of the first to move into the morning sky, the morning northeastern sky. Saturn's trying to catch up with it there, and you can see the sun is, we are going into winter, the sun is declining, but Mercury should be visible for those a little bit on the desperate side to see it, particularly 20th of next month, 20th of June. When it'll be nice and cold in the morning.
It's still possible to see the planets at the end of the day.
Huh?
It's still possible to see the planets on the horizon at the end of the day.
Well,
I saw
at the
them
moment...
I saw them last week.
Oh yeah, the you know, Jupiter, Saturn and Mars, yes. But you're not going to see Mercury now until it belts up into the
No, I
morning
didn't
sky.
couldn't see Mercury.
Yeah.
Yeah. But in the evening now, Mercury is not visible in the evening, or it is?
Not at the moment, no.
You can't see it.
No. The only planets you're going to see now are Jupiter, Saturn, Jupiter, Mars and Saturn, and Venus. Venus is slowly doing its turn around to rise up. We'll show you that in a minute.
Yeah, at the one time about 6 in the evening, isn't it?
Yes, yeah, but now Mercury is history until it moves as here. So, you know, all right? And that's what you want to see with the evening sky. Clearly Venus is a goer and Jupiter's declining. So Venus, Jupiter are definitely goers. Mars may be, You can consider Saturn virtually history, unless you're really, really quick. So there you go. And on Sky for the Month, I think you've got 2 shots of a waxing crescent moon for the 15th of each month, 15th of May and the 15th of June, where it's close to those planets. But Venus will be a goer, and it's obviously, and see by the curve, it's going to rise quite high already for late this month, the 27th. Okay? So we will all be happy with Venus rising in the western sky.
This is the blue one?
Yeah, the blue one, yes, yes, the blue one.
The blue one's Venus?
The blue one's Venus, it always has been for 4 years on the computer stuff.
Well, I can't find a legend on it.
Oh, Bruce, it's every bloody blue planet in the sky. Jeez.
It almost looks white, doesn't it?
Trust me. Okay. Now, I have to admit that I'm partial to the north eastern sky at the moment. That's the 1st of June. There is an absolute stack there. You've got our Milky Way descending in the near northeastern sky, I beg your pardon, southeastern sky, and you've got in the northwestern sky, you've got absolute stacks of galaxies and lovely little bits and pieces. Now, what? Okay, now, on a later program, there are 2 areas that I've blown up. One is the realm of galaxies between Leo and Virgo, the realm of galaxies. Also a blow up of M49. And 2 interesting doubles, mu beauties there and epsilon beauties. Okay, the charts are on Sky for the Month, so the rest, I mean, all of them are easy objects. I've even knocked out the right galaxies there. Anyway, whatever. I've been naughty because I found the northern sky quite challenging with the computer because I've constructed many galaxies. The southern sky is still lovely, and here I've done the southeastern sky. You've got a nice waning crescent, I'll get it right actually. A waning gibbous moon to brighten up things. Okay, but seriously, we've got the beautiful area of Sagittarius rising, which I forgot to do an outline. Scorpius. Ophiuchus is okay, there are lots of globulars in it. Not much in Libra. I will point out a recurrent nova, which I think is that one there, RS Libra, okay? It's magnitude 12, don't rush it. And the rest of us know, with respect to Briar's nights and viewing nights, that we've still got our Milky Way descending into the western sky. It's still very, very lovely. Okay, but I haven't really done much for the southern sky because it's been a challenge to muck around with the northern sky, which we'll go to now. Okay, northern sky. The triple, I think it was, hang on, I'll do that again. I think it was Mu Butis, I think. Alright, this is where I showed you Mu Butis before. It's a red star. It's a very close double. Even with large binoculars, and that's with large binoculars now, the blue companion only starts to nudge out, okay? It's a close double. I think the separation is 3 seconds. Don't rush it unless you've got large binoculars or a scope, okay? But it's seriously a contrasting nice double. Epsilon booties. Rightio? Epsilon booties, it's marked on the chart. Nothing's missed. And if you hit it with a telescope, it splits. And there you go. And there is another companion, and that's magnitude 11. Okay? I don't know what the colour of that one is, so it's left as white. Magnitude 11, and that's all a true triple with the primary. I think that's really orange-red, but I didn't have enough time to set it up as a lovely orange-red. And there's a companion. Very close, okay? Very close. Note. All right. Our famous M49 galaxy. Whoops. I'll show you where it is. I forgot to do that. Okay, try again. All right, we all know about Virgo, okay? Perimeter, Vindimetrix, Denobola, that's back in Leo, okay? So you've got the end of Leo here, ending in Denobola. You've got Perimeter up there. There's the outline of Virgo and Vindimetrix. You've got M49 up there, and you've got a stack of galaxies down here. That's where I'm concentrating on right now. So let's enjoy ourselves. Only joking. Right now. Now the first one's M49, which you can't, oh yes you can see with large binoculars. That's M49, okay? But slightly exaggerated. You'll be lucky to see it with ordinary binoculars, okay? It disappears. Ordinary binoculars, 7x50s probably won't get it. Not around Frankston. And if you hit it with a real lot of magnification, it looks good. And that's pretty realistic. There is a central core and there is an outlying area, and it is oriented that way. Trust me. Alright. The next one, the biggie, the realm of galaxies. And I've chosen strictly the brightest. Again, I've shown you where it is. It's in that Virgo area. You won't see them with ordinary binoculars. You'll just start to see them with large binoculars, and there they are. I didn't have time to construct those two. There's M87. They look as you see them. There's a little twerpy M90. There's M60. That looks like a circular fuzzball. See? It's pretty good, isn't it? Anyway, don't answer that. And if we hit it with a telescope, there's a bit of a blow up into the central area, which is M89. I didn't mean for it to have a spiral arm in it. I don't know why that's happened. I'm going to have to sort of figure that one out. I tried to knock that see the little spirals in it? Something's happened there which shouldn't have happened. And,
it's evolving.
What?
It's evolving.
Yeah, it's evolving, yeah. I could do that. Alright, that's it for those galaxies. They're easy. Oops, I didn't mean to do that. Oops. I'll cheat. The wrong button here. Okay. The binary Mu-Butis, it's fairly good. Again, with binoculars, not much go. It's got a nice feel. Now there's Mu-Butis, okay? You can see the primary just in the top of it. So it's coming out. It's all set up there, but it's not there yet. And the primary is a little bit of a red colour. It's not showing that red colour up too well. Anyway, there you go. And there are two other companions. That's Mu-Butis, all right? There are two other companions. They're magnitude 7 and 7.6, but there's no separation of positional angles, so I can't rig it. But they exist. Two more magnitude 7s, but no one seems to have the information on them. All right, and last but not least, this is a bit of a dead loss, this one, but never mind, I'll show it to you. It's good to show dead losses. All right, this is Sabig up in Libra, and the centre of this will be the recurrent nova RS Libra, with a bit of luck. It doesn't sort of tell you much, but it's good fun. So you don't see it, and you do see it, because it's the only magnitude 11 one there. So that last one was a bit of a disaster. Well, it's not a disaster, it just doesn't go anywhere. All right, I'm done.
Roger there for skylights, and we'll follow that by Ian Sullivan, if he's in here. Yes, he's in here. Yeah. And then Bruce.
Now, right. Okay. All right. Yeah.
aurora, go and have a look and call up the next person, which worked last month, worked up the night of the last meeting, after we went home, and also the following night. Due to a couple of things happening in my life, I need to relinquish the operation of that network. Basically, from the 30th of June, I'm looking for someone to take it over. Anyone who's interested to run the show, come and see me after the meeting. And you've got email access, because you can send messages around, update the phone list and things like that fairly easily. A few people on the network who don't have that, and we use ordinary mail, but it's a lot easier to pick up those done. So yeah, come and see me. We'll organise something for whoever wants to take it over from me. Okay, May highlights. April the 17th, it's the night of the last meeting. There was a coronal mass ejection, and this sort of struck the Earth's atmosphere on April the 17th. This show might be a bit funny tonight because I sort of shortened it down to fit it into the time frame, which probably expanded a bit now. We've got about an 18-hour geomagnetic storm, and we, on that night of the meeting, we swung the network into action, and phone calls all around, and quite a few people made some positive observations, which is unusual because this KP index, which is like a measure of the strength of the Earth's magnetic field, usually needs to get above 8 before we sort of see auroras in our area. It was only 6 that night, and it really wasn't expected. This here just shows the line. You can see the red line there at the top, that curve 9 comes across southern Australia. The 7 goes from central Tasmania. They say basically if you're south of that line, you will see auroras. So the index needs to get up to about 5 before you sort of 6 before you get to the southern tip of New Zealand. 8 is just brushing Australia. With an index of 6, we really shouldn't have seen anything up here, but we did. That's the graph of taking every few hours on the showing what the index is. Sort of up and down a bit, but did reach up to 7 at one stage. A lot of people saw lots of auroras. Nice glow after sunset. Very nice display, it says. Oh, no hands. So we back and saw a nice display. Lots of detail. This is in the northern United States again. Wisconsin, April 19th. Some of these, there was like a double night. We had there for a couple of nights. That's a nice one. Some really nice colours. There's just so many different patterns, and a nice building in the foreground. Very bright, that one, but not a lot of colour in it. Finland, a nice band with some rays. Yukon, behind a bit of cloud there. Twisted band. Auroraville, Wisconsin. Yeah, that's good. It's great. Nicely take some good shots. Really good colour. Some of these people are very experienced in aurora photos now. That was the first night, and then April the 18th, there's a bit of anomalies these days because it depends on sort of on their UT dates or local dates, and they're in the US or here and this sort of stuff. That activity lasted for about 24 hours, and the next night there was, again, phone calls went out, there's auroras visible, I think I can see the flame cloud, etc. I observed for about an hour and a half, and saw for about the first hour of that saw activity, red glow patches. I was observing from south of Berwick, looking due south. There was some to the southeast, some to the southwest, some due south, sort of white beams rising up from the horizon. Didn't get any photos, sorry to say, but also lower than what we'd expect. Only got up to a 7. You can sort of see there the first night over here, which was the previous night, and then sort of 24 hours later it was up there again. So it's a pretty good show though. That's spectacular. It occurred because of a combination of circumstances. The solar wind speed increased, and this Earth's magnetic field BZ component, which is the north-south component, turns south. That allows the solar wind and charged particles from the sun to interact with the Earth's magnetic field. You can see this here, this component is sort of turned towards the south, and the solar wind speed up here, gone up to 500. These things are sort of updated every 15 minutes on the internet, so sort of like monitoring this sort of thing and the messages that come out, you get a fair idea when there may or may not be auroras. Every so often one pops up unexpectedly, and other times there's all the conditions seem right, nothing happens, but it's a pretty good indication if you want to keep an eye on what's happening. Now this is from the Thursday night. This was at 8:54. I was actually on the internet at the time, and it dropped out and the phone went, and I went back on before I actually went out to observe. And this here is Australia. It's up here. This is just the sort of southern coast of Victoria here. This is the intensity of the auroral activity, and it's actually to measure the proton flux, I think it is, or it's units of ergs per square centimetre per second. It's taken from satellites, yeah, a polar orbiting satellite, and it basically measures the intensity of the solar particles, protons, electrons, etc., coming into the Earth's atmosphere. This oval expands and contracts as the intensity levels go up and down, and it's just getting up sort of towards where it's the lower part of it, and the lowest intensity is starting to touch southern Australia. That was, as I say, at 8:54 p.m. is the time on that image. It's not really an image, but it's like a photograph from space, but it just measures the intensity. The next one was at 11:42 p.m. after I'd finished observing. You can see how the activity has subsided and it's gone right back down again to a much lower level. What's that? Let's come back to that in a fairly short time. The activity level on the side here is given as 8. This one was 10. So, yeah, there was...
Any idea why it's stronger on the side near Australia than on the other?
Yeah, that's the side opposite the sun. The red arrow points towards the direction of the sun.
Oh, yeah.
That's sort of getting towards local midnight. And it's always strong on the side, away from the sun. And the little black dot there in the middle is the south geographical pole. The oval itself is centred around the south magnetic pole.
The south magnetic pole, but is actually the same longitude as Melbourne, roundabout.
Yeah, that's why we're...
Yeah, I've just discovered that recently.
Yeah. Now this is once again some images from the northern hemisphere. Really very diverse.
You mentioned the solar wind before. It says 500. Was it 500 metres a second? That speed. Kilometres a second. Yeah, kilometres. Yeah. Does it fluctuate much?
Yeah, it's when it gets faster, that's what it helps to. When it gets fast, it's more energetic, and this is when it's fluctuating. It's sort of the magnetic field's unstable and allows it to come through. Nice mountains down there. Cloud, showing up through the cloud. New Zealand, okay, there was one. See those vertical white rays? That's what I saw from Cleverdon Tram, and similar to that. Pulsating, moving. One side says that you can actually see a change in the intensity of the pattern, shooting across the sky from one side to the other about the speed of a meteor, from north to south across the sky. All sky camera photo, China lens. This is all this same night, this sort of April 19th, 20th, depending on where you were in relation to the date line. Nice rays and colours. Yeah, the patch is being illuminated from north to south in direction at approximately the same speed as the street in Meteor. It's quite a good display. Stars. Yeah, April 23rd, the twisted magnetic fields above sunspot 9906 erupted. And you can see that there on the bottom right. There's a really strong projection into space. There was pretty close to the limb of the sun, actually, that one. And usually when that happens, we don't get much happen to the Earth because it's not directed towards the Earth. But the coronal mass ejection, now this one is an interesting one. I didn't show the earlier one. This one was so intense that the charged particles, as they sort of hit the detector on the spacecraft, actually caused like noise or hash. You can see all that sort of white speckly stuff. That's just protons and stuff like that going through the detector, solid state detectors they use to actually measure to image the ejection. And it's caused quite, not only this detectors in this spacecraft, but a lot of the others as well, to get overloaded and lots of noise and hash come on them until it had passed. It's quite a intense one. It did deliver a glancing blow to the Earth's magnetosphere, and the flux of high energy protons saw 10,000-fold. That's, it's really, you can see that's a logarithmic scale there. It's really gone up from about 1 up to 1,000. Really a solid blast. And the timing was just right for the observers in North America again at their longitude. They were getting it at night. It lasted for 3 to 5 hours, so by the time it got round to the thrust said that its intensity had subsided again. It didn't last very long at the higher intensity. Might be the earlier one. And a couple of very small meters on there. Lots of stars in that one as well. They just take all sorts of shapes and colours. A couple of planets there. Aurora again. Come out through here. This guy's got a snowmobile up in the mountains, and set up his tent. Yeah, be a nice yeah. So he just hops in his snowmobile and goes up in the mountains, sets up his tent and starts to observe every mountain. Like she said, he did tell about a piece carving off a glacier, and gave him a bit of a fright. Ghostly looking auroras. 10 million angels dancing in the heavens. And May the 12th, a few days ago, interplanetary shock waves put past the Earth. A bit of a surprising on this one, so there wasn't a lot of expectation of anything happening, sort of caught them unawares a little bit. Triggered a geomagnetic storm, which lasted for about 12 hours. The magnetic field turned south again, and yeah, after sunset on the 11th of May, there's the impact of the solar wind. An iridium satellite flare was seen at the same time. That's it, folks. That's all right.
Another colourful presentation. Okay, Ian, you want to do your slideshow, followed by Bruce?
What about the pointer? I was in New Zealand in January, and I happened to go through a town which is Hamilton in North Island, New Zealand, and I knew in advance because somebody had given me slides years ago of a particular sundial in Hamilton. Unfortunately, of course, I could ask around where is it and found it, and then I took some photographs of it. I already had a few given to me, but I looked it up and there it was. So we'll have a look at it now. And it has particular significance, I'll explain as we go along. Here's the first slide. Go Jakob. Oh, I reckon I go forward, don't I? I just go like that. And there's the first slide. Right, okay. Now, you'd almost walk past without seeing there was a sundial there. Can you see it? Almost looks like a trash can, doesn't it? You see it here? Not all that big. In a sort of a shopping area. A shopping mall. Get a bit closer, there's my daughter next to it. And it's not just an ordinary sundial. You can see there's a lot of sundials in one. Now, you can see on the top you've got a flat surface, and obviously that would be the horizontal sundial. So there's your gnomon on top for the horizontal sundial. And this one on this side, which would this be, north or south? Oh. Yes, because you see your gnomon on top on a horizontal sundial point to the celestial pole. And this is south, and in fact Hamilton is latitude 37 south, which is very similar to Melbourne. So, so it's hardly any different to Melbourne. So that's south, this is north, this way. And facing north you have this surface here. This is an anemometric sundial. The tip of that casts a shadow on that. We'll have a bit more magnification in a second. Do you see you've got a sundial here on this face facing north? That is a what? That's obviously vertical. So what do you call it? You call it a vertical dial, and normally I suppose the commonest, most symmetrical vertical dial is one that faces exactly due north and cops the sun and casts a shadow, and you can read it all day long. You've got your hour lines, and it's quite analogous really to the horizontal sundial. Your hour lines are not equal distance around. There's just the horizontal line on top, and your hour lines, as you go away from the noon position, the hour lines, the angle between hour lines increases. The further south or north you go, further away from the equator, then the greater this is accentuated. Now, this is the anemometric sundial, and you can see that tip there casts a shadow on the surface, and you see the figure of 8 drawn. The analemma is drawn, and the tip migrates around, comes on, and then you get a position each day. But it works, it's got dates for the whole year, and it works its way. It's right down here, of course, in summertime, and it works its way up here in wintertime when the sun's low. So you've got a position there, and it's all marked out. Now, either side, of course, we've got, what do you reckon we'd have on this side? This, of course, is north, and that means facing north. This will be
West.
East. This is facing right, this will be east. So this would be a easterly dial, which would be read when? Mornings, right. So you only have the hours up till noon on this dial. And then on the other side, there's a west facing dial. There is the The horizontal says horizon dial, horizontal dial. Yeah, this one here. It's not exactly very sharp, is it? But nevertheless, it's I don't think I can. No, go back one. Yeah. Can you get a focus? And you're on a focus thing here. That makes it work. Is that better? That's better. Yeah. Lot better, yeah. Yeah, okay. And that's got equation of time figures on it. That's all that does. Tells you what to add and what to subtract. And of course, as you can see, that the lines are typical. Not all easy to see, but nevertheless, there it is. Now, this sundial was set up. I think we've got it on the. This was. Oh, well, here we got another one here. What do you reckon that one is? That is a. That is. What? Sorry, that's horizontal. Now, what's this one? We haven't got this one. This is facing south, and this one is what? Equatorial. Yes, equatorial. That is in the plane of the equator, and that faces south. Now, notice that our lines equal angles. They should be 15 degrees. But down here, what have we got here?
It's a vertical one facing south.
It's a vertical one facing south. Yep, south vertical dial. But not good, since the sun goes across the northern sky, you'd only catch it when the sun is actually around here, right, the other side. You only catch it in summertime, would you? We wouldn't do much good. But nevertheless, they wanted to pack every possible dial onto the one. Well, interesting that it was constructed in 1953. Did anybody give a significant date to why that's significant? There's the South Equatorial dial. Why 1953? How many royalists have we got here who watched the program last night? Yes, who watched the program about royalty last night? And what happened in 1953? The Queen, yes, Queen Elizabeth II was crowned. Not only that, Queen Elizabeth II visited New Zealand in that year. Didn't visit Australia, visited Australia in 54. But for the Queen's visit, this sundial was constructed. And it wasn't a professional job, apparently. There was an astronomical society in Hamilton, which is a town about the size of Geelong. That's all, it's 100,000 people. And I don't know if that society still exists, but there's a little plaque there, and we might even see it on the... there it is. Focus with the focus in north. Focus. Is that better? Now it says presented by Hamilton Astronomical Society to commemorate the visit to Hamilton of Her Majesty Queen Elizabeth II, 1953. And there's a date there. December 30th and 31st. Right, so there we are. And this is what? What's the style? East vertical, right? Now what do you do when you get to east vertical? You get, when you read it only in the morning. Now what do you reckon this line would be? That's at the equinox. Yeah, and this one here, of course, is summer solstice, which of course is December. Sun's high in the sky. This is winter solstice. The west vertical dial, similarly, winter solstice, summer solstice, and equinox for the afternoon. And this is the analytic dial. And here's the point here.
Time and date on there?
Actually, no, sorry, it's not the tip that you use, it's the hole. That's the hole. Let's come back to that here. See there's a hole in it? And the hole, the little dot down here. I just happened to be there. It was right at the end of the limit of the, right down the bottom here. Came through about there. Yeah. Was coming through about
So what dates were you there again? January?
Don't forget, it'll only be on the line when? On that analytic, it'll only be on the line what time of the day? At sundial noon. It'll be on the line, actually on the line.
Yeah, what
Yeah.
date were you in?
That was the end of December.
December.
Yeah, so that's why it's down here.
Why is that hole off centre, Ian?
I don't know why they put it there. Anyway, that's what it's meant to be. It's what they say here on the... Unfortunately, I didn't take a macro lens. You really need to have a macro lens in your camera to get up close to photograph these dials. I didn't have one with me, unfortunately. That was
the difference between local time and like zone time?
Well, don't forget, in an automatic sundial, that movement up or down is in fact the declination of the sun.
Yeah, I just went by the holes off centre because
I see.
Hamilton is not in the centre of their time zone, so they're going to go down 4 minutes per.
Yeah, I don't know, I'm not sure that one. No. But anyway, that's the declination, whereas your equation of time, if sun fast, sun slow, the speed equation of time is of course left-right situation. Alright, that's, and that one, you see now, this is the state of it, this must have been, you see how it's all worn away, it's all, the plating has all come off. And that is the south vertical dial. Yeah, you see it's only the end of the day, end or beginning in the summertime that you can read that. Now this is the one in particular that interests us because I recommend, no decision being made yet, that we have a sundial at the prize. And I recommend this one. And the reason why I recommend having one like that, they're quite a bit unusual. Not horizontal sundials all over the place, everybody's got one. And the other thing is you can read the declination of the sun continuously. You'll get a figure, you'll get a value, won't be dead accurate, and you'll get time. You can read the time and you can read the declination of the sun. This is in the plane of what? No, it's on the plane of the Earth's axis. Yeah, and of course it faces north. And this spike, you see, goes up there and points to the equator. So that's the idea of it.
So it's equivalent to our latitude.
Equivalent to our latitude. Well, the angle will be set by the, yeah, that's right. But the fact is that the axis, yeah, that's right. So the plate, that plate will be parallel, as I said, to the Earth's axis. And that runs to the Earth's axis, doesn't it? So it's parallel to the gnomon, yeah, the face here. So.
Would you call it a polar sundial?
Yes, call it a polar dial. And you get the readings, you see the curve, and there's a formula for working out where these lines go. Sundials Australia is a company in Adelaide. I've had a talk to them, and they make these sorts of things. They'll work out that they key it into the computer and out come the figures. So that might be a problem. That's not all that easy to read, as you see it, but yeah, some called them. Anyway, I haven't got much of a shadow here. Must have not much shadow.
It's close to midday.
There's a shadow here.
It's midday.
Yeah.
That's why
Shadow there. I'm not getting there. Virtually no shadow. Yeah.
Well, very close to midday.
Yeah.
midday end of December, so
Yes. Well, no, midday at the equinox. Midday at the equinox, you'd have no shadow at all.
Yeah. What was the date when you were there?
Oh, it wasn't equinox. It was December. Huh? But I'm not sure. Don't forget this. These slides are mixed with some when I was there, some of this other guy took the pictures. But I don't know which slide that is. Now, the fellow in Adelaide, this is Dr. Ward in Adelaide, he just made this for someone else. And you notice that he doesn't use a spike, he hasn't used a spike, he's used a plate, a gnomon, and you cast a shadow like so. Now, we don't want that because we want to be able to read declination. Obviously, somebody is only interested in reading the time. You've got the equation of time. The other things we could have on it if we want is the zodiac signs, some zodiac signs on it in the appropriate positions. And we could put the, obviously have the Frankston logo, a whole lot of bits and pieces we can have on this sundial and make it a spike, but of course the spike has to be made of submarine titanium steel, the hardest, toughest steel like that. vandal trip. There'll be a challenge to every vandal from Torquay to Melbourne, right, to come and bend it over or break it or wreck it. We'll have to get about over 2 or 3 spares in this case in the shed there. You see, the reason for having that, you see, this doesn't seem to entice the vandals to the same extent. You see one like that. But if you put a spike there, there you are. They come out of the woodwork. All right. So anyway, that's still to be discussed. So we've got to make a decision on what we have, and it'll look good when it finally is installed.
We've got a spike on an insulated base to 5,000 volts now.
Yeah, we don't see if anybody touches it, right? And we'll make it razor sharp, right? Something like that. Anybody falls on it, it's sharp. Yeah. Okay, thank you.
And Bruce, you can be yours. By the time.
Okay, well, I'll make it fairly brief, but as far as the sun's concerned, well, Roger has covered quite a lot about the sun already tonight. I had a look at the sun this afternoon, and there are only a couple of reasonable sized spots visible, one in the eastern hemisphere, one in the western hemisphere, and just a few other tiny spots there. But I did notice on the internet that, as Roger mentioned, there was a coronal mass ejection a few days ago, and of course they did observe the aurora as he was showing us, particularly in North America over the last few nights. Does anyone here see anything in the last few nights? Apparently not. No. Well, the other thing I was going to mention, you've all heard the expression once in a blue moon, and did anyone see the article in today's Age about blue moons? Looks like no one did. Okay, well, it's only a fairly short article, so I thought it was fairly interesting. Now, there are 5 things you should know about blue moons. This journalist says, and the journalist is Liz Minchin. I don't know whether anyone knows her, but anyway, one of the things is that first one is true blue. It's very rare, but there have been times when the moon has actually looked blue, usually as a result of smoke or ash after a volcanic eruption. I thought usually it looks red, but anyway, she says it looks blue. And when Krakatoa erupted in 1883, countries as far away as Turkey had blue moons for more than a month. Green and turquoise moons have also been seen. The dense cloud of particles in the upper atmosphere filters out most of the red end of the visible light spectrum, leaving only the green-blue end, resulting in a very strange-looking moon. Now, the term "once in a blue moon," the first known printed use of the term blue moon, meaning something that is patently untrue, was in 1528, when a short Elizabethan poem, Read Me and Be Not Wroth, was published. If they say the moon is blue, we must believe that it is true. But as years passed and there were more sightings of blue-coloured moons around the world, once in a blue moon became a popular expression for extremely rare events. And the next main item, mooning culture. There are plenty of references to blue moons in Western culture, and most have nothing to do with cold weather and bare backsides. Elvis Presley made them famous with his 1956 hit Blue Moon, and he sang "Blue Moon, You Saw Me Standing Alone," etc., as well as with his remake of Blue Moon of Kentucky, while Canadian indie electronic artist Wiggy released Once in a Blue Moon last year. There's also the Blue Moon cocktail made with curacao, gin and a lemon twist. But maybe you have that when you see a blue moon. And the next thing is on green cheesy lunatics. If you believe any of the hundreds of websites out there, there's no such thing as a blue moon. It's actually green and made of cheese. The urban myth is so prevalent, particularly in the United States, that even serious websites feel they need to debunk it. For instance, a companion website to a documentary on the US Public Broadcasting Service only half-jokingly says the moon is not made of green cheese but of bits of the Earth blasted into outer space by a Mars-sized meteor which struck our planet 4.5 billion years ago. More recently, English news website Ananova reported that a Cambridge University admissions tutor asked a would-be veterinary science student if the moon is made of cheese. astronomers will tell you that a blue moon is the second full moon in a single calendar month. But this modern definition is actually based on a mistake in a 1946 edition of Sky and Telescope. Before then it was much more complicated. The yearly calendar was split into 4 seasons leading up to the winter solstice, and if there were 4 full moons in a season, then the third was called the blue moon. The next blue moon, according to the new definition, will be in July 2004. In 1999 there were 2 blue moons, but that won't happen again until 2018. So that's it.
All right, at that I'll close May's meeting and commend you all to come here next month for June's meeting. Thank you very much for coming.
You all right with this, or do you want to do this next one? Yeah? Tell me what you find out.
I know we'll drink most of it. My wife hasn't dropped me in there.
What's the website you want to do?
Oh, yeah, okay. It's called spaceweather.com.
Yeah, I know that. I noticed you said last weekend. So that's all right. So I'll give that telescope to Greg Watt.
There are other secrets, but
Well, I mean, I can take this scope home.
Okay, you're there. Have a look at it. Let's know what.
So there were.
Did you want one of these? You were the one who wanted one of these. I've only got one left now. Did Peter Skilton?
Okay.
Yeah. Did you want? Who wanted one?
Yeah, I wanted one.
Yeah.
The only thing is, I don't think I've
Yep,
got
I've got some $5. So I got one for Don because he wanted about 4. He's only going to get one. I didn't get the right one.
No worries, thanks. Okay. Good, excellent. Okay, now hang on, I've got to go and find Greg.
Yeah,
Yes.
give me that thing, Rob's in this box.
That goes in the box. Yeah, that goes in that.
Yeah, you take it.
So after the variety was popular, I printed out 15, there's only one left. Oh, no, you can have it if you want to make this on for the first time.
It's quite easy to find. I'll get some copies.
Oh, man, I can print out, or I can email the orders a PDF, PDF.
I'll be going to Josephine all the time. I wonder if there's anyone.
On the original Corel draw format, I can give you an email you with PDF format if you like.
Not really fun, I might come back.
Yeah, well, as I said, I can email you the PDF and then
Yeah, do that. I can bring it up, yeah. Is that girl next to the leaders?
I don't know.
David will be driving me home, I hope.
Yes.
He's vice president, isn't it?
Yeah.
Okay, that is phenomenal.
What's the problem?
That's mine, right? Personal.
Let's give out of it.
Where's the committee meeting?
Because somebody's already had a,
Yeah.
so the IR goes in here.
Sean, do you want to help pull that table
Yeah,
down?
I
Or
goes
is
in
it
there.
stayed
I don't know.
there?
I assume it gets pulled down.
Yeah, that needs to go out there somewhere. I'm not sure where it came from.
Library. Library.
Peter, that committee meeting is next. Committee meeting is next Wednesday.
I think so. yet to double check that.
What? At where?
Oh, it would be a fireplace.
Yeah. But what you asked about the place or the time?
The time or the day.
The day. Right.
Yeah. Oh, right, okay.
This is to the,
You right?
Yep.
And you'll advise by email, will you?
Yeah.
Right? Yeah, okay, now I got that. Okay, I'm going to help Peter get stuff outside.
I also think we will give you a little meteorite box as well. If you're talking to some schools around here, so you have a sample to sort of take around there.
How many?
So we got plenty of fragments of debris, and get a clear back in like that. Oh yeah, you got to remember.
So yeah, I've got a take type.
Yeah, it makes the point very clearly that they're magnetic.
But it's been shaped, isn't it? But it's Meteor material. It's Meteor material.
No, that's definitely terrestrial substances there.
Well, what's the
Yeah, so what I basically do is I hand around that and the meteorite together. So they fill it in because it's so strong, it's very, very clearly.
You know how I
something's I've got a few more. I've got a box there. That one I just got from Bunnings for about $5.
Good job with your news there.
Yeah, I mean, I'm certainly interested. Oh yeah, box away that was
Well, I can show you one thing, you won't be that.
That's right.
You'll love it, Roger, you really will. Oh, thank you. How much for it around?
$5. $5. So give it to me tonight.
Just pick out for the car and get it.
What